In this lecture, we're going to talk about these three rules of dimensioning: the contour rule, the no dimensioning to hidden lines rule, and the no duplicate dimensions rule. Beginning with the contour rule. What this rule says is, you must dimension a feature in the view where it appears true size and shape. Here's an L-shaped bracket. I think we saw this one last week. Here it is again. So L-shaped bracket, if you're going to dimension the thickness of this horizontal leg, you have to do it in this view where you actually see the leg, not in the side view. In the side view, all you see is a line, and you don't know what that is. Here's a part, two versions of a part. This is an L-shaped bracket. In the side view, we see that the vertical leg has a rectangular notch cut in it. In the top view, we see that the horizontal leg has a radiused end and a circular hole in it. So let's look at why this example at the top is screaming no at you, and why the example in the bottom is saying yes. First of all, up in the bad one, there's the thickness of that leg, 10 millimeters. And by the way, how do I know this is metric? Because there are no trailing zeros. Anyhow, so that 10 millimeter is in the wrong place. Down in the good drawing, there we see the correct place to put it. Up in the bad drawing, there is 9 millimeters thickness on this vertical leg, but this is the wrong place to put it, because that's not true size and shape. We'll look at the view at the bottom. There is the 9 millimeter dimension in the view where it appears true size and shape. And finally, how about this notch? Again, in the bad drawing, these are just lines. We don't know what they are. Down here in the good drawing, there we see, oh, that's a notch, and that's what those numbers are talking about. Now let's keep looking at this drawing. Up here in the bad drawing, there is a 45 millimeter dimension, the overall length of this part, and this is something we never want to do. Do not dimension to the end of a round thing. It does not match the way it's manufactured, and it's very hard to measure that with a measuring tool accurately. It's easy for your caliper or whatever you've got to slip around. So the correct way to measure a round thing is shown in the bottom version. Give the location of the center line, and then give the radius. And this is an example of what ASME calls functional dimensioning, and what they mean by that is this matches the way the part will actually be made out in the machine shop or wherever it's getting made. So the person in the shop will locate the center of this arc, the 30, and then they will put a radiused end on it. That was the contour rule. Let's think about hidden lines. We are not allowed to dimension to hidden lines ever. I don't know of an exception. So never dimension to hidden lines, period. There you are. So here's a part with a notch in it. If you need to show that, that 10 millimeter height, you don't want to show it over here in the no side for two reasons. One, that's not true size and shape, and two, it's hidden. So here in the whatever you call this view, you can see that notch true size and shape, and it's visible. Let's go back to this part again. Thinking about that notch cut out again. In the bad drawing, here's the height of that notch dimensioned to a hidden line. How can we avoid that? Let's go down to the bottom example. in this side view, that notch is visible, and we can put our dimension there. What about this hole? We do not want to dimension the diameter of that hole on the hidden lines, obviously. We want to put that dimension in the view where it's visible and where we see the hole true size and shape. Third rule, no duplicate dimensions. This one is a little more subtle. It takes some getting used to. So in the bad drawing on the left, someone has gotten real thorough and just dimensioned the heck out of this thing, which you might think, oh, that's very good, that's thorough, but no, it's not. These are all duplicate dimensions, and there are a couple of problems with that. One is something called tolerance stack-up, which we'll look at in a couple of weeks. And the other is that if you give the same dimension multiple places, and then you come along next year and you revise the drawing. You say, oh, you know what, that shouldn't have been 20, that should have been 19. So you revise it there, but you forget that you also had that same dimension down here, and so you forget to change that. Now you send your drawing out to the shop with these duplicate dimensions. And what if your machinist notices this 20 down here and makes the part that way, does not notice that you changed this one to 19, so a bad part gets made. It's not their fault because there was still a dimension on there. Here's a part. It's a bracket with a flat ledge and two ears sticking up and a couple of holes on the bottom and a couple of holes in the ears. So this particular drawing, if you study it for a while, you will notice that there are 3 sets of duplicate dimensions. And let's see whether we can find those. First of all, you might notice the overall length. See how there's an overall length in the top view and the front view? You only want one of those. And probably you want the one in the top view because it is in between the two views, and that's preferable if we can do it. Okay, where else? How about the height? That 1-inch height is duplicated. It's shown in 2 views, and maybe we want to keep the one in the side view because it is in between 2 views. Now the third duplicate might be a little bit harder to spot, for the reason that it is actually located in 2 views that are not sitting right next to each other. That 1 1/4 inch dimension. We see the width in the top view and we see the width in the front view. So we should eliminate one of those. And you could pick which one you wanted. This part also has duplicate dimensions. And there are actually 2 instances of that. One of them is in the width here. The 20, 15, 20, that's fine, but they've also given an overall width, and we can't have all of those. We can only have, any 3 of those. And we will see why when we talk about tolerancing in the near future. So the other duplicate dimensions are here in the height. 10 plus 20 adds up to 30. So 10 and 20 are duplicates of the overall height. You have to pick any 2. And this is a good time to go out to your shop and ask them which of those dimensions work the best for you. Which ones do you want? If you want to have all of those dimensions, as we see in this ASME example, so here are the 3 dimensions plus the overall. If you really want those, what you have to do is make one of them a reference dimension, and you do that by putting parentheses around the dimension. So that's what you see in this first stepped part. over here in this thing that looks like a kazoo, there are two 34 millimeter widths and then an overall width. And if you decide that you want both the 34s, you can still include the overall, but you need to make it a reference dimension by putting parentheses around it. And what that reference dimension means is no one is allowed to manufacture to that dimension, and no inspector is allowed to inspect that dimension. It is only there for their reference. It's to be helpful. It's extra information for their reference, but we cannot hold anything to it. So keep that in mind. Pick the dimensions that you want your title block tolerances to apply to, and make the other one the reference. And as I keep saying, we'll look at this some more when we look at tolerances. I just threw this in. This is the part we're going to draw today, and this is a part that was drawn by Anonymous. This drawing is so bad that no one wants to put their name on this. Actually, between you and me, I drew this, but I am not putting my name on this monstrosity. What's wrong with this drawing? Honestly, what's right with this drawing? Almost nothing is right with this drawing. Everything about it is bad, from the leading zeros to the text style, to these dimensions not lining up, to the duplicate dimensions, to the dimensioning to a hidden line, to not dimensioning where it's true size and shape, to a crossing dimension. The dimension is too close. The title block is funky. It's just bad, bad, bad. Oh yeah, and the lines are not drawn on the right layer. See how everything is a thin line? These should be thick. So bad, very bad. Here's the part we're going to draw, and dimension. And as I mentioned here in this note, I gave you a 3D CAD model to help you in case you have trouble visualizing what this thing looks like. So here I'm going to get my 3D orbit and just orbit around and start to get a view of, oh, I see how this thing is cut out and where the notches are and where the stair steps are and so forth. I'll just throw in a hint here. We were, one of our class and I were looking at this drawing the other day, and this toolbar here was missing. And so we thought, well, let's just hack around and see if we can figure out where to find that toolbar. And I was thinking, because it has to do with viewing, we might go to the View tab. And sure enough, in the View tab, bunch of stuff here, blah, blah, blah. But one of the things in the View tab is over here, navigation bar. Look what happens when I click navigation bar off. See, that bar disappeared. Watch it appear again when I click this thing. Boink, there it is. And how about the view cube, this view cube here? Ah, it went away. Now I'll click view cube again, and there it is. So I couldn't remember where it was, so I just thought, well, that has to do with view. I think I'll just look there. So here is a 3D model for you if you find it helpful.